Hello, my name is Ibrahim Nahwa, and this is the final section in about fractals. And now I'll be talking about fractals in nature. First thing, let's recap about what a fractal really is. Fractals are self-similar patterns that repeat at every scale, zoom in or out, and at the same structure appears again and again. From the branching trees and rivers to the spirals of ferns and snowflakes, nature is filled with these infinite patterns. Fractals emerge wherever growth, chaos, and geometry intersect, revealing a hidden mathematical order beneath the surface of the natural world. Fractals in nature. So, where are some of the more common places that we would see a fractal? Plants are among the most striking examples of natural fractals. Ferns display self-similar fronds, where each leaflet mirrors the shape of the whole leaf. Trees branch repeatedly in fractal patterns, with each bough splitting into smaller limbs that echo the overall structure of the tree at every scale. In the geology, the natural world's geological formations reveal stunning fractal geometry. Mountain ranges, repeated jagged silhouettes at every scale, from vast peaks down to an individual rock faces. Um, River systems branch into tributaries that mirror the whole network, and coastlines display infinite detail no matter how closely they are examined. In biology, the human body relies on fractal architecture to function efficiently. Lungs branch through bronchi into bronchioles and alveoli, maximizing surface area within a compact space. The blood vessels networks divide from arteries into capillaries in self-similar patterns, ensuring every cell receives oxygen through nature's most elegant fractals design. Some of the examples of these are lightning bolts. Lightning branches in self-similar patterns, with each fork splitting into smaller forks that mirror the whole fleeting fractal etched into the sky. Nautilus shells grows in a precise logarithmic spiral, each new chamber a scale replica of the last, the nature's most elegant fractal curve. Romanesco broccoli. Each spiral floret of Romanesco is a miniature copy of the whole head, repeating in a logarithmic spiral that follows the Fibonacci sequence perfectly. River deltas. Rivers split into tributaries that split again into smaller streams, creating branching fractal networks that distribute water across vast landscapes. Let's compare what a mathematical versus a natural fractal looks like. The Mandelbrot set reveals infinite self-similar complexity through pure mathematics. In nature, you would find fern fronds that mirror the same branching fractal patterns found in equations. Thank you so much for watching this video with me. Now I will show you some of the more uh, tools, for example. This is a website called Visnos, where you could create your own fractals in a much more simpler format. Let me go ahead and set this up. So angle 1 here is the angle of each of the second pendulum, as you can see here, which uh, creates like a chaos effect where it would branch off. It also uh, creates the angle for every single branch. So, for example, if I set this all the way up to 180, you would get a perfectly straight line, since every single branch is also set at 180. Angle 2 here is the angle of the entire system itself. So if I set this to 180 as well, you would see it's also a straight line. If I were to put it back to 360, so um, with each difference in angle here, you would get a completely different fractal, as you can see here. There's also branches. So how many times would you like to branch from each n? As you can see, it gets really chaotic really fast, as every single branch is being split into three. I could reduce the amount of iterations it needs to go on for, and we would see a much more simpler format of this entire structure. You may be able to create simpler shapes, for example, like this one, but more often than not, you would create something a lot more chaotic. Let's look at another example. This here is a website that gives us documentation about fractal generation. Here we see some of the more simpler formulas that are used for the fundamentals of fractal theory, where each function begins with a formula zn plus 1 equal to function of zn. Uh, then we also have the sequence of values z0 until infinity is called orbit. Here it also explains something about the Julia set versus the Mandelbrot set. It's a great website if you want to dive deeper into fractals. You would be able to see example right here. This is an example of a Julia set. As you can see, we can't really zoom in currently, but there are areas of this fractal where they are not connected, which is important because when we move on to the Mandelbrot section, uh, it's completely different. It's a lot more colored. It is color coded, and in this one you could zoom in and you can see that it's a repeating pattern. If I were to shift zoom out of this and go into a different area, you would see the same pattern repeating again and again. For example, I go here. The same pattern would repeat again and again. This is what a fractal is. So thank you so much for coming to my explanation. I hope I was useful in some way. Uh, Thank you.